Hi, my name's Geoff, Senior Product Specialist here at Scientifica, and today we thought we'd go through the components required for DIC on the SliceScope. So on a SliceScope, we like DIC because our customers typically are working in live tissue, brain slices, which can't be stained. So we need some method to create contrast. One of the ways we do that is with differential interference contrast. So the first component you meet in DIC is the polarizer. Then you'll go through, at the bottom here, a quarter wave plate. Then again inside the condenser, you have an objective specific prism. At that point, you're going through your sample, through the objective, and you meet a nosepiece prism, and then finally the analyzer. So now I'm going to mount all of the DIC components onto the SliceScope, and then we can go through what each of them does and how you interact with them. Polarizer, or quarter wave plate and objective specific prism. The nosepiece prism, and the analyzer. So very briefly, you start off with your polarizer, which polarizes the light. You then have a quarter wave plate, which is a way to introduce bias. Inside the condenser here, you've got your objective specific prism, which spatially separates that polarized light. It can then go through the sample at slightly different positions, get interacted with differently by the sample. That then gets collected by the objective and then hits our nosepiece prism, which spatially brings those polarized light together. That then hits your analyzer and creates the DIC effect. Interacting with DIC on the SliceScope is really very simple and localized around the polarizer and your quarter wave plates. All the other components are fixed, and you can spin your polarizer to align it or misalign it with the analyzer at the top. You can create the largest DIC effect by creating the darkest image, getting the most interference, and you can ease that back a little bit. It's based on what you need for your cells and what works for you. Another very individual preference is the position of the quarter wave plate. Again, it's a case of spinning it around and creating an image that feels good to you. You can sort of see cells maybe coming up as convex or concave as you move that through, whichever works for you. And so you can adjust the quarter wave plate by spinning it around, finding a place that makes the membrane most visible to you, and then you can lock it in using the pin there. So thanks for watching. I hope there was some useful information in there. If you want more information, go onto Scientifica's website and find our resource center. There's a detailed description of DIC, which goes into much more detail, and loads of other useful information too.